Hi and welcome to a webinar on DFMPro, a fast and easy way to have automated CAD integrated manufacturability checks for injection molding designs. It will help you save your time, save a lot of effort, and ultimately reduce cost of your products. We'll start with a brief introduction about Geometric. Geometric started as a part of the Godrej Group, which is one of the well-known and largest software solutions, engineering solutions, and have a diversified suite of products and technologies in various areas. Let's move on with the presentation on DFMPro. DFMPro helps you get your designs right the first time. As a global engineering organization, as we provide solutions and talk with our customers on a day-to-day basis from our customers, which we keep on hearing on a day-to-day basis. All customers are focused on addressing their time to market, ensuring quality, controlling their production costs, and at the same time, continuously innovating in the market. However, each of these goals has certain bottlenecks. For example, schedule may be affected due to rework or lower productivity. Quality may be affected due to manufacturing defects. Expensive tooling and scrap can escalate your production costs. And when engineers get bogged down by schedule, quality, and cost problems, innovation starts taking a backseat. Traditionally, the design to production cycle has exhibited the kind of graphs shown on the right. These graphs show the impact of a change in design as it moves downstream. For example, the later in the design to manufacturing cycle you originate a design change, it's going to cost you exponentially more. This typically happens because designers may not be aware of the manufacturing rules and best practices early in the product development cycle. This can lead to increased number of change requests, wastage of material, and lower production yields. To avoid a trial and error process and a lot of iterations between design and manufacturing, it is very useful if we can provide some tool to the designer to leverage the manufacturing knowledge while the design is getting created. Because of the traditional method of taking the designs downstream into manufacturing, we see the kind of change request cycle shown on the screen. You have the design getting created upstream within the design environment in your CAD system. Then it moves downstream into manufacturing, assembly. From each of these downstream departments, you have change requests which originate due to various reasons. In many cases, a change request may originate because of manufacturing and assembly problems. The design is sent back to the designer for changes and corrections. Now this kind of iteration happens repeatedly with the design getting created, shipped downstream, modified according to a change request. This affects the time to market, resulting in a longer timeline and delayed schedules. Now if we concentrate on the injection molded components or plastics in general, what are the kind of requirements which a plastic product or injection molded product will have? First of all, aesthetics are very important. It is crucial that the product has a smooth surface finish. Sinks and warps and sharp corners need to be avoided. This is primarily because many plastic products get used as consumer goods, as casings, as toys. So ensuring that your products are free of such defects is very important. These products need to have adequate strength to ensure that they provide great use for its end users and live its complete life cycle. There are various guidelines for this. For example, we need to avoid heavy sections. The materials should flow smoothly from thick to thin sections. To ensure that we have a increased tool life, designers must avoid features which will require EDM processes which take time and also cost a lot more. These are just some of the areas which we need to concentrate on to have a good plastic product or a good injection molded product. Now we have seen the traditional method of working from design to manufacturing. We have seen what are the typical requirements from a plastic product. Now to ensure that the requirements downstream, that is from the manufacturing department or the mold shop, related to the tooling requirements, to the aesthetics, are addressed early in the life cycle, way back a concept called DFM was introduced, which is called Design for Manufacturing. The traditional method of handling DFM reviews included maintenance of DFM checklists, guidelines, and handbooks. Designers were trained periodically on the manufacturing rules and best practices. There were frequent reviews between the designer and his peers and seniors in the organization. There were frequent consultations between design and manufacturing departments. However, each of these manual methods of practicing DFM has certain problems. A manual review of a design can be very time consuming. Detecting sharp corners, detecting thick walls can have a lot of time which is spent in this review. It could also be possible that due to human errors, some problems may escape. It can lead to inconsistent design quality. For reviews between design and manufacturing, we need proximity between these departments, which is not always possible. To conduct a design review or a DFM review for a plastic component, which are the typical guidelines which must be addressed? This slide talks of some of these guidelines. For example, we need to ensure that there are no sharp corners in the component. Like the image on the left hand side, we need to ensure that the tip and the base of the boss in this part is filleted. The image on the left hand side bottom shows the need for adequate mold wall thickness. The clearance between these ribs will decide the thickness of the mold, and if this is less than the adequate value, it's going to cause problems in the life of the mold and even the manufacturing of the mold. Adequate draft angles are necessary to ensure that the product can be easily extracted from the mold. Ribs, which are very crucial for ensuring the strength of the part, can also cause problems in aesthetics and in the cooling of the part. So we need to ensure that they have adequate drafts, they have adequate height, and they have adequate thickness. Undercuts can be a problem in manufacturing. They impact the manufacturing time and the manufacturing cost. So we need to ensure that wherever possible, you can avoid undercuts. And one of the most important areas to consider for a plastic component is the variation in wall thickness. We need to ensure that the smooth flow of material can be ensured at all times during the manufacture of the part. Sharp corners need to be avoided, appropriate radii need to be provided. These are just some of those guidelines. Based on the complexity of the model and the number of guidelines to be checked, based on the materials, the kind of checks, the kind of data to be referred will just expand, and it can take a lot of time and effort to thoroughly check a given design for ensuring that it is easy to manufacture using injection molding. To help organizations facilitate this process, Geometric has a product called DFMPro, which helps in upstream manufacturability validation. It will help users quickly identify areas of a design which can be difficult, expensive, or impossible to manufacture. You want to check for thick ribs, you want to check for undercuts, you can very quickly perform these checks. DFMPro helps users automate the iterative design review process for manufacturability. So if it takes a couple of hours to go through a design, verify the draft angles, verify the wall thickness variations, check for adequate parameters for a rib, for a boss, using DFMPro, it can be possible within minutes. In addition to the standard checks, DFMPro also provides a mechanism using which you can capture the manufacturing knowledge within the organization and reuse it for continuous improvement. This slide shows how the traditional design to manufacturing cycle will be transformed using DFMPro. The specific rules for designing, for manufacturing and assembly are now brought upstream and made available within the design environment within the CAD system. Due to this, the iterations can now happen on the designer's desktop, thus avoiding the lot of time which is spent in iterations between design and manufacturing. Since the iterations are directly on the designer's desktop with respect to the manufacturing rules and guidelines laid down by those departments, it is going to save a lot of time and rework. This will ultimately help reduce the time to market, produce a better product of higher quality and lower cost. DFMPro some benefits at many levels. For the design engineers, it offers a quick and interactive feedback while designing. They can learn on the job. Manufacturing engineers are assured of a tool which will ensure consistent level of design quality. And for the organization as a whole, it offers a framework to capture and reuse the manufacturing knowledge within the organization. It will help shrink the time to market right from concept to act. Today we will be focusing on the injection molding rules. These rules ship out of the box along with the product and allow users to use them without any efforts. It's possible to configure each and every rule to suit your requirements based on your manufacturing conditions. In addition to the standard rules, you can also customize the product. You can either write your own rules using Visual Basic for users having access to SolidWorks and Pro Engineer. We have add-in tightly integrated within these CAD systems. For other users, for example, users working with CATIA or NX, we have a standalone application which can take in imported CAD data or data from these systems and analyze it in the. At this point,